Hey, Lee students, you're looking at it. This here is the command center. This is where I sit down to do your lessons. This is where I grade your papers and your tests. This is where I come up with all of those crazy random ideas. This is also where I sit down to do my homework for Cal Poly. All that crazy fancy math that the professors make me do. This is where it all happens. And you know what, speaking about lessons, remember yesterday's video, how at the end I mentioned my niece's birthday party and how that this was the gift package that I was gonna give her? Well, just in case you don't have Twitter, would you like to see what was inside? Boom, that's the content therein. I know she wanted this, and boy, you should have seen her reaction. You know, someone asked me, oh, Mr. Lee, that must have been really expensive. It must have cost you a fortune. Well, duh, but my response to that is, who cares? It's just money, and money is meant to be spent. Besides, when I saw things like this, boy, there's no price to that. That is priceless. So I just thought I'd share that with you guys. So now let's switch gears and let's do some math. Today I'd like to try 2 problems, and that'll be it for this week. Solve for theta, comma, where theta, we want theta to be between 0 and 360. So we want 2 cosine squared theta minus 1 to equal 0. So what can we do to this equation to make it look simpler? We can do little things like we can move the 1 across and then we can divide by 2. That'll tell us that cosine squared theta equals 1/2. And now you know what? This can be expressed with a slightly different type of notation, like that. Now what we want is for that square to be gone. So we can square root the left and the right. So that here it's just cosine of theta. And on this side, first of all, because there's a square root, we need a plus minus. And on your calculator, if you type in the square root of 1/2, it's gonna say square root 2/2. Now here, this creates 2 different branches. So in one setup, we have cosine theta equals positive square root 2/2. And then over here somewhere, we have cosine theta equals negative square root 2/2. So now we have 2 equations that look just like yesterday's material. So recall how this works. Cosine theta is an x-coordinate. So check out your unit circle. Where on the unit circle do you see x-coordinates that say square root 2/2? That happens at these 2 locations right here. So for this first part, theta equals 45 degrees, or theta can equal 315 degrees. This baby equation here has a negative. So where on the unit circle is your x-coordinate this number? Well, that's going to happen at 135 or at 225. So all together as a team, these 4 pieces constitute your solution set. Done. And also really quickly notice how that all of your answers, they all individually satisfy this condition that your answer be something between 0 and 360, which all of these are. So let's try one more and we're out of here. Last one for this week, guys. 2 sine squared theta minus sine theta minus 1 equals 0. Unlike the previous problem, if I were to move this to this side, it doesn't really do me any good because this middle piece, it's sort of screwing things up. So this problem has to be treated differently, especially since I have 3 pieces where one of them is squared. So here what I would recommend is that we create a u substitution. So allow us to let u equal sine of theta. We can now immediately rewrite the original problem in terms of u. So 2 stays, but instead of sine squared, well, what's sine? Sine is u. So this would be u squared, subtraction. What can replace sine? U. Minus 1 equals 0. Now we're faced with this equation here. How can I solve this equation? Well, it is a quadratic equation. So I could go quadratic formula, knock yourself out if you want, but I prefer to employ the idea of factorization. Recall that this can be factorized. If you wish to employ mental math with me, this can be factorized into the following. 2u, 1, that's negative, that's positive. Still equals 0. How exactly did I go from here to here? 20 years of experience. But just to quickly remind you how you can go from here to here, you can take 3 pieces and do one of these ones. And that will turn 3 pieces into 4 pieces. Then you can go group factorization, and it'll eventually take you back to this here. But again, if you don't like to use factoring, just go quadratic formula. Now that we've done factoring, let's go zero product property. Let the first piece equal 0. Let the other piece equal 0. Solve each of the 2 equations. This here, if you subtract 1 divided by 2, this tells you that u is a negative half. Here, slide the 1 across, u equals 1. So we have the values of u, but we want the values of theta. So what can replace u? Sine theta. So this becomes sine theta equals a negative half. Sine theta equals 1. So now treat these individual equations the way you treated yesterday's equations. Let's go here first if you want. Recall that on the unit circle, sine of theta is y. So I want my y coordinate to be 1. Yes. I want my y coordinate to equal 1. Look at your unit circle. Where do you have a y coordinate of 1? Well, I only see one location, up here. So that means that for this equation, this theta is 90 degrees. Let's play with this one here. Look at your unit circle. Where do you see a y coordinate equaling negative 1/2? Well, I see that here and here. So this equation produces these values of theta. What are they? They were 210 degrees and 330 degrees. So altogether, your solution's set. So please try the attached exit ticket and then send me one picture that has all the work from this week. No math tomorrow. Have a lovely weekend, and I'll talk to you guys on Monday.